we will be recording from the current slide. All right, before we get started, any questions on anything we've covered so far? Okay. Today, this is the last little bit in section 6.4, which is the last little bit we're going to cover before the test on Wednesday. And today we're looking at determining the nature and roots of quadratic equations. Now, this has limited impact on the test probably, because most of these, if they're factorable, you're going to factor them. But if you do use the quadratic equation, this tells you something about what your answer is going to be. The quadratic formula, can anyone tell me what it is now? Quadratic formula. X equal, or the variable equals what? Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, very good. Now, notice that radical there. The square root of b squared minus 4ac. That determines what kind of solution you get. Okay? Because you see, the minus b is just a number. And remember, our numbers, our coefficients, are any real numbers. They're not complex numbers. And so far, we're going to use only, I think, integers. Okay? Can't think of any problems we're going to use that even have fractions in them. But they could be. But whatever they are, the minus b is just a real number. 2a is just a real number. The rest of this is under here. Okay? That radical is going to be, most of the time, what introduces either radical answers, in other words, irrational numbers, or complex numbers, because it's what's going on in there that appears under the radical sign is called the discriminant, because that discriminates what kind of answer you're going to get. Okay? And here's how it does so. Here is, as you already have said, discriminant is the indicator of the kind of roots the equation has. For example, here's the equation. X squared minus 4x plus 7 equals 0. Can we use the quadratic formula there? Why? It's in standard form, that's a 0. That's absolutely correct. If that was anything other than a 0, don't you subtract it, add it, do whatever it takes to make a 0 out there. But once you get it in standard form, now you identify your A, 1, B, negative 4, C, 7. Okay? So, as you already gave me the quadratic formula, you just plug it in. Minus B, which would be a minus a negative 4, which becomes a plus 4, plus or minus the square root of that negative 4 squared minus 4 times 1 times 7. 1 times 7, AC. Okay? And all divided by 2 times 1. Okay? There's your denominator. So what does this give you? Positive 4 plus or minus negative 4 squared is 16 minus 4 times 1 times 7, only one minus sign, so this stays minus, and this gives you 28. Now, when you see this pop up here, this is your discriminant. What does that tell you right now? Anything? That's going to be negative. It's going to be a negative 12 under there. What does that tell you about the answer? You take the square root of a negative 12. Not in the real number system. So your answer, when you get this far, no real solutions. Now the book's going to take it a little bit further, and that's fine, because they're going to assume you know about complex numbers. Well, you do know about them, but we're not going to test you on that. Not yet. That'll be in a later course. Okay? So you can write down, as soon as you see this happen with the quadratic formula, no real solutions. None. Okay? Now, we'll carry on. That gave you 4 plus or minus square root of negative 12 over 2. At this stage, you should be able to look ahead and realize you will obtain two non-real complex solutions for the equation. Note, by the way, those solutions are complex conjugates of each other. You don't need to know that for this course. You already do know it because we went over it just quickly. But in other words, the discriminant minus 12, what's inside that radical, indicates the type of root you're going to get. If it's a negative number, no real solutions. What if it's a positive number, like positive 12? What would that tell you about the answer? That would mean 12 is not a perfect square. You cannot take the square root of a non-perfect square, so that means you have irrational solutions. So if the discriminant is not a perfect square, your solution is irrational. It is real, but it's irrational. You don't need to know that either because we are only dealing with rational ones so far. 2 chapters away, we'll deal with irrational numbers. Okay? Now, what if this thing is a perfect square? Then what kind of solution do you have? Rational, because you can take the square root of a perfect square, and that's going to give you 2 fractional forms. Now, you might lose the denominator, and maybe not all of them are fractional. This is David, right? Josh, I'm sorry, I said it backwards. There were 2 pounds in here. Josh. There you go. Good deal. Goodness, that light is bright. Okay, so if this is a perfect square, that gives you 2 rational solutions. The other thing that tells you is you could have factored that polynomial to begin with, okay, that quadratic form to begin with. This might be easier to do it this way. It's perfectly fine. Now, one more question. The book doesn't harp on this. What if that discriminant is a 0? What does that tell you? You only have one solution, 4 over 2, which is 2. If that discriminant is a 0, you only have one solution. If that discriminant is not a 0, you have 2 solutions. They may be 2 rational solutions, 2 irrational solutions, or 2 complex solutions, but you always have 2 unless that discriminant is 0. If the discriminant is 0, you get 1. That means you have the double root. Okay? So you see how much that tells you. So if you have a big, hairy, ugly quadratic equation and you are trying to determine what to do with it, why don't you just first look at the discriminant? B squared minus 4AC. See what it is. If it's a perfect square, that means you can factor that if you want to, or you can use the quadratic formula to tell you. If it's a negative number, hang it up, Jack, no real solutions. If it's not a perfect square, and you can say irrational, no rational solutions. And that's all you need to say for this course. If it's 0, though, then you can say, hey, there's only one solution, and it is minus b over 2a. That is your solution. So you see, just knowing the discriminant could make your life a little bit easier. Okay? It can help. If you did want to go back and factor the solution, it can give you a hint on what those factors should be. So that's all we're going to say about it now. Any questions about the discriminant? Okay? A pretty important thing to look at when you are trying to solve a quadratic equation. It may save you a lot of trial and error and other type things. See what the discriminant says. It's pretty easy to do. So, here's how they say it. We make the following general statements relative to the roots of the quadratic equation of the form ax squared plus bx plus c is equal to 0. We call that the standard form. Make sure that's a 0 over there. You have these in this order. Then, if your b squared minus 4 times a times c is less than 0, no real solutions. Complex numbers, but we're not dealing with those. No real solutions. That's if that thing's negative. If that thing's equal to 0, then you only have one real solution. And I'll tell you what it is now. minus b over 2a. That's it, okay? You got it knocked, okay? If it's greater than 0, then the equation has two real solutions. What they don't mention is you could take it one more step. If it's greater than 0 and is a perfect square, they're rational solutions. If it's greater than 0 but not a perfect square, then they're irrational solutions. So you can take it one more step than what they do. Okay? Does that make sense? Pretty helpful little tool to have. So the following examples illustrate each kind of these situations. It says you may want to solve the equations completely to verify. So let's do this one. Okay? What would be your discriminant for that first equation? Okay, which is 9. Okay. Normally it's minus, and you look at the signs of A and C, those are both positive, so it stays a minus. And what is it? Times AC? Yes, it's a negative 28. So this was a plus 9 when you squared it. Minus 28, what do you know? Second? It's going to be a negative, so therefore what does that tell you? No real solutions. Hang it up right there. You get a negative number. Who cares what the negative number is? It is two real complex solutions. All you care about, no real solutions. Okay, how about this one? Might need a calculator for this one. No, not 9 squared. B squared. Yeah. Anyone know what that is? 144. And then it's minus 4 times this times this. Again, that's going to be a negative. Okay? So what's 4 times 4 is 16. 16 times 9 is? 144. So what's your discriminant? 0. What does that tell you? 1 and only one solution. Can you tell me what that solution is? Is what? It's minus b, which would be 12 over 2a. 2 times 9 is 18. 12 over 18 is 2/3. You got the answer right there without doing anything else. All they said, one real solution, we know that. That's absolutely true. How about this one? 2x squared minus 5x, plus 5x minus 3. What's your discriminant? Say again. 5 squared, which is 25. What sign? Okay, you got a minus 4, and then 1 minus here. That's going to be a plus. Guess what? Right there, you know the discriminant is going to be positive. That means you either have two rational solutions or two irrational solutions. What's going to make the difference? If it's a perfect square or not. So let's see if it's a perfect square. 25 was this squared plus 4 times 2 times 3. 2 times 3 is? 4 times, 6 is 24. And you had a 25 plus 24 is 49. Perfect square. 2 rational solutions, exactly. They say 2 real solutions. You know it better than that. You know it's 2 rational solutions. Guess what that also meant? You could have factored that if you wanted to. Don't have to. You already got the answer halfway done with the quadratic formula. See? Does that make sense? It's just sort of a handy little tool. Since we did the quadratic formula, it can help you take care of a problem pretty quickly if you just figure out and process that discriminant. Any questions on that? Okay. So let's do example 6 here. Use the discriminant to determine if the equation 5x squared plus 2x plus 7 equals 0 has 2 non-real complex solutions, in other words, no real solutions, 1 real solution, with a multiplicity of 2. We haven't talked about that, but that is true. Or, and then I would say I would break that down. 2 rational solutions or 2 irrational solutions. Both of those would be real solutions. So let's determine, you take it one more step, rational or irrational. Okay? How would you do it? Whoops, let me get my pen activated. Okay. How would you do it? B squared minus 4AC. What's your B? 2. 2 squared minus 4 times, okay, 5 times 7, okay? I can't write, but there it is. I think you can probably tell what's going to go on here now right away, can't you? Second? I can't hear you. I can still can't hear you. She said 35. 35. Well, okay, these two are 35. Times 4, negative 4 is going to be a big negative number, right? That's a little positive number. Guess what the answer is? Say again? Okay, negative 140 plus 4 is negative 136. No real solutions. As soon as you see this big negative here, a small positive here, who cares what the numbers are? No real solution. Now, if you were dealing with complex numbers, yeah, you take it out and figure out what that is. But we're not. No real solutions. In other words, in their thing, 2 non-real complex solutions. That's the answer they're looking for. Let's see if they got it. Okay, let me erase this from the slide and see what we got. From the equation, they did exactly like you did, and they got 4 minus 140, exactly what you got, which is negative 136, which, guess what, is a negative number. So therefore, you have 2 non-real complex number solutions. All you have to say, no real solutions. Okay? Make sense? When you get in higher level math, you can do the other part. This one, no real solutions. All right? Okay. And I'm pretty sure, no, there is one more, I believe. So let's go back and do that one. Example 7. Solve this one. 3x squared minus 8x plus 2 equals 0. First thing you ask yourself is what? Is that in standard form? Yes, it is. Okay, then what was the next question? Or answer? Say again? Yes, find the discriminant. What would it be? And let's see, what that's when they say solve it. So we're going to try to solve it. Let's start with the discriminant. What is the discriminant? Negative 8 squared, that should be squared, minus 4 times 3 times 2. Okay? What's negative 8 squared? 64. Minus 24 equal 40, not just 40, right? Okay, what can you tell me there? It's a positive number, so you know got real solutions. But what can you tell me about that positive number? So the next question you ask yourself. Is it a perfect square or not? No, it isn't, so therefore it's 2 irrational solutions. And since we don't care about irrational solutions yet, we will when we do a couple chapters later. All we say now is no rational solutions. There are 2 real solutions, but rational, so we're not going to solve it. We're just going to let it go. Okay? 2 irrational solutions. No rational solutions. So you couldn't have factored anything else. If you look at the answer they do in the book, it's 4 plus or minus the square root of 10 over 3. We're not doing those yet. We will in 2 chapters, but we're not doing them yet. Concept quiz, good thing to look at. They're true, false. You won't see many of those on the test. Homework exercises, I think I've given most of these to you before. But let me go over them again now. You can probably tell me as fast as I can. Uh, 19, 29. Am I missing any? Second. Okay. 19, 29, 31, 33, 37, 45. That's all so far. Okay. Now you can do the next group. 51. Let's see if I can find 53. 57. Okay. You can do those three. I think that's going to be it for the as far as we're going to go here. There's a good section, 6.5, more on quadratic equations applications. You don't need to worry with those now. A few of those do indeed have real solutions. Sort of to follow up, and again, I'm going to do this one just because I have seen something similar to this on a final exam before. I don't know if it'll be on this one or not, but something. Let's just flip the page to 324. I'm going to erase the ink on this slide. And again, this isn't going to be on your test, but I do want you to see this type of problem. 3 over n plus 10 over n plus 6 is equal to 1. How would you go about solving a problem such as that? Let me give you a hint. What's messy about that problem? Say again? Yeah, well, denominators. Let me just, it's in the denominators. Now, since this is an equation, we have a pretty easy way to get rid of denominators. What is that? Well, in fact, what do you usually do when you have denominators? Now, if you're multiplying and dividing, you just deal with it, okay? But if you're adding or subtraction, which we are here, what are you going to need to do? When you have a denominator, you look for the common denominator. And since we don't even know what they are, what do? If you don't have any other choice, you multiply them together. So your common denominator is going to be the product of those. And what are we going to do with that? Multiply every term on both sides by that common denominator. N times n plus 6. This will be n times n plus 6. And this is times n plus 6. That's legal, right? Multiplying the same thing by both sides of the equation is fine. Now, the only time that's not a good idea to do is if either one of those denominators were 0. But guess what? If either one were 0, you can't solve the problem anyway because you can never divide by 0. So you're guaranteed they're not 0, so let's go with it. Now, let's look at just that first term there. What you notice about that will simplify. N over n is equal to what? 1. So you can divide out the 1. Okay? So that leaves you for this first term, 3 times n plus 6, which would be 3n plus 18. Very good. Now let's look at the second term. What can simplify there? N plus 6's go out, right? Because they're dating. No, I'm just, okay. What does that leave you? Plus 10n is equal to, a little louder, n squared plus 6n. Got it. Okay, you made the left-hand side much simpler, right? You got rid of those denominators. We don't like denominators, do we? Okay, if we can get rid of them, we do. Right-hand side, we got a little more complicated, but we can deal with that. What would be the next thing you would do? Combine like terms, and what does that give you? 13n plus 18 is equal to n squared plus 6n. Very good. Now what? Okay, which would you move? 13n, is that what you said? Or the n squared? 13n, I would do that. Is that what you said? I can't hear. Okay, sorry. Now here's what I like to do. Here's my rationale. I like to have my quadratic term positive. So there's no quadratic term here. There's one here is positive. I want to go that way. Okay? Now if that was a negative, move it this way. If you had a 2n squared here and an n squared there, move it this way. Move it to the biggest positive number. Okay? And move them all. Okay? So that what that would do would then be minus 13n minus 18. This will be a minus 13n minus 18. What does your left-hand side become? 0. Your right-hand side becomes n squared minus 7n minus 18. Now, how would you solve that? It's up to you. Second? You can use a quadratic formula if you'd like. How would that go? Okay, n is equal to, what do you say? Oh, you're going to do the discriminant first. Is that right? Second? I can't hear. Okay, yeah, okay. Okay, we're doing the discriminant first. Negative 7 squared minus 4 times 1 times negative 18. Y'all are good. What does negative 7 squared give you? 49. Goodness, I can't write. Okay. Okay. Let me try that again. Okay. 49. Count those negatives. Plus, is that what again? 72? Okay, I can't hear. What does that add to? 121. Anyone know anything about 121? 11 what? It's a perfect square. So what's our answer? I mean, let's go on and do it. Let's go back to the quadratic formula now. We know that n is equal to, how does it begin? Minus b plus or minus the square root of 121 over, you see, you've already done that work. Don't go back and do it again. That discriminant was 121, okay? Over what? 2a, okay? So this is, say again? Negative of negative 7, which is 7 plus or minus, and what you told me what that was? 11 over, say again? 2 times 1, right? 2. Okay? So what is our solution? N is equal to 7 plus 11 over 2, or 7 minus 11 over 2. Okay, what's 7 plus 11 over 2? It's what? 18 halves, is that what you said?
18 over 2.
Yeah, and what does that give you? 9. And over here you have? Say again? Nope. 7 minus 11 is? Negative 4 over 2, which is? Is what? Negative 2. Fantastic. Way to go. Okay? It's a little bit different kind of problem. I don't think you'll see any quite as difficult on this test, but you might see something like it on the final. So I just wanted to give you the experience of doing something like that. Pretty simple process, just one step at a time and go through it. And you can check your answer, or you can look in the book and see what they got, -2 and 9. They did. Okay? The next one's pretty straightforward. If you want to see it, I'll do it. Example 3. Interested in seeing? Okay, y'all want that up a little longer? Okay. Y'all need, how about example 3? Say again? Up to you. Yay or nay?
Is it on the test?
This problem isn't on the test, but I can't say there's not going to be one similar to it. It's up to you.
Are we going to be something like this on the test?
Well, I mean, it's one similar to others we've done. There's nothing real magical about it. It's just bigger numbers.
I mean, the only thing really different is the first step that you did. Right?
Oh, yeah. On this one, the thing is you had your variable in the denominator. It's an equation. Trying to solve the equation. How will you do that? That's one. Say again? What's that? You want, like, example 3, it's not like this one, but it's just another example. Interested or not?
I'll take another example.
Huh?
I'll take another example.
Okay. Let's do example 2. And it's just, this is one more like what we've already done. X squared plus 22x plus 112 equals 0. It's just bigger numbers is all it is. So what would you do? How would you solve this problem? What would be your approach to it? Remember, you have several tools under your belt now. You have factoring, and in factoring, you trial and error, or you can use AC method. You could do completing the square. Yes, I know y'all all love that one. Or quadratic formula. You want to do quadratic formula? Where would you begin? Say again? Okay, you want to do the discriminant. So let's do b squared minus 4ac. What is that going to be in this problem? 22 squared minus 4 times 1 times 112. Okay? Calculator time. 22 squared, I think, is 242, isn't it? No, 240, no. 484, I'm sorry. I had it going in the right direction, but didn't do it correctly. Okay? That would be 484 minus 448. And what does that give you? 36, is that what you said? What does that tell you? It's a perfect square, so you're going to get 2 real for sure, because it's positive. Because it's a perfect square, you're going to get even better than that. 2 rational solutions. Fantastic. So what will those solutions be? X equal minus 22 plus or minus, can't we go on and take the square root of that? 6 over 2. Right? Boy, that discriminant speeds things along, doesn't it? What are these 2 answers going to be then? Negative 22 plus 6 over 2, or 22 minus 6. Oh, that's a minus 22 minus 6 over 2. I wish I'd have done something first. Want me to show you what that is? Let's just divide out the 2 into both of those. That'll be minus 11 plus or minus 3, right? That's a lot easier than that. What's minus 11 plus or minus 3? That's either going to be negative 11 plus 3 or negative 11 minus 3. What's negative 11 plus 3? -8 or -14. I can't write. Okay, let me see if I can clean that up some. Okay, -14. All right, let's see how the book. Oh, they got it right too. Good for them. Okay. All right. That one wasn't too bad, but it's up to you whether you want to do. You got all these techniques, you choose. Okay? Just looking ahead, there's a few word problems. I know y'all love those, so I'll let you do those on your own. And the rest are, I think, a little more involved than probably what you'll see on the final. So, ready to go. Any other questions? Chapter 3, 4, Chapter 3 or Chapter 6? Okay. Let me, at the same time, give you a few other hints here. If you turn back to the end of the Chapter 6, remember, you don't need to know much about complex numbers. I introduced you to it, but that's all. Okay? So the objectives, the first, on page 337, the first, second, third, in fact, I'd say all those objectives on that page, don't even worry with them. Okay, on the next page, 338, the first one don't worry with, but the next one, solving quadratic equations by factoring, yes. We've already done that. Solving quadratic equations in the form x squared is equal to x squared minus a, you can do that, especially if that a is a perfect square. Okay, you know how to do it if it's not, but we're not going to worry about them. Completing the square, you need to know that, and the quadratic formula, you need to know that. Nature of roots of the quadratic equation, that's fine, and then the rest of them you don't need to mess with because that's beyond what we're doing. Anything 6-5 or beyond we're not messing with. However, the solving problems pertaining to right triangles and 30, 60, 90 triangles, that would be a good one. And let's see, why they put 6.2 in the middle of 6.5, I'm not sure, but it's there. So those would be some good things to look at. On the review problem set, again, those with complex numbers, don't worry with them. But beginning with number 21, here are a few more you can look at. 21, 23. 37, 39, 41, 47, 49, and then I think probably that's it. Let's see. No, maybe 67. You might see something like that. And it looks like, yeah, I believe that's all you'll need. That was pages 342 and 343. Then there's also the Chapter 6 test, and I think all these answers are in the back of the book. So you could do, I'll tell you which ones you could do here. 3, 4, 5, 10, 11, 12, 14. Say again? I think all the answers for the chapter test are in there. It's just not on the others you're not. So those are other things if you just need some more things to look at. All right, any questions? All right, I think that's the last, well, we've already done this one. Okay. So let's move on and get started. And before I get a howl of protest, what we're going to do in Chapter 4 builds on what we did in Chapter 3 and 6, and is just going to be nothing but an extra thing. You're not responsible for this on the test, but it will be good things that you need to remember how to do. So, let's end this one and go back one here and here and go to Chapter 4, Rational Expressions. All right, this is another long chapter, but hopefully it'll go a little faster because you have all the tools you need for it right now. Okay? So, well, what is this to and quit? Okay. All right. Rational expressions. Boy, it's almost this. They're building this house, but it almost looks like what they're doing, getting ready for the hurricane to come in. Same type of thing. What we're going to do first is simplify rational expressions, which is basically what we did in Chapter 3 and some in 4, but we had a different reason for doing it then. Second? This is Chapter 4, yes. Two objectives. First, we're going to reduce rational numbers, and secondly, we're going to simplify rational expressions. Okay? Start with numbers, go to expressions. We have reviewed the basic operations with rational numbers in an informal setting. In this review, we relied primarily on your knowledge of arithmetic. That was earlier. Now, we want to become a little more formal with the review so that we can use the work with rational numbers as a basis for doing rational expressions. We'll define what a rational expression is shortly. Okay, we're going to get to it. You'll recall that any number, and this is what we're going to do, let's talk about what a rational number is. Does anyone remember what the definition of a rational number is? Anyone? What's the first 5 letters of rational? Ratio. What does a ratio mean? Say again? I can't hear it. You maybe give me the right answer. I just don't know. What is a fraction? That's exactly what it is. What are you doing with a fraction? What operation are you performing? Division. That's what a rational number is. It's one number divided by another number. Now, what are those numbers in a rational expression? Ratio of 2 integers. A ratio of 2 integers with one pretty important but pretty small exception. And that is that denominator cannot be 0. Okay? Numerator can be any number in the world. They're integers now. You're counting numbers and they're negatives. Any one, including 0. The denominator can be any one of those counting numbers and they're negatives, but cannot be 0. Okay? That's what we mean by rational number. You'll recall that any number that can be written in the form a over b, where a and b are integers, as long as b is not equal to 0, that's called a rational number. Now, another form for a rational number, any fraction, you can write as a decimal. How will those decimals look? They'll either be terminating decimal, like 1 over 2 is, what decimal number? 0.5. 1 over 3 is 0.333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333. repeats itself forever. Okay? So any decimal number that repeats not just one digit, any number of digits anywhere in it, and just picks it up and starts repeating forever, that's a rational number. So decimal numbers that either terminate or at some point repeat, those are also rational numbers. But if you got a calculator, somebody that can do it, plug in the square root of 2 and see what you get. Not all the phones will do it. Oh, okay. I thought you were. Okay. Square root of 2. You can see that one in the dark, can't you? Okay. 1.4142136. You see any pattern there? if you had a calculator that had a big enough display, it would go on and on and on and on, and you never see a pattern. That's an irrational number. If you do 11 divided by 3, what do you get? Say that again. Oh, not. Okay, yeah, and so that's repeating. Oh, you said on and on. Okay, I got you. So you see anything that repeats. How about, I said it backwards, 3 over 11. That's what I really meant to say. What do you notice there? 3 divided by 11. 2, 7, 2, 7, 2, 7, 2, 7. See the pattern? It just keeps repeating. Square root of 2 never develops a pattern like that. Okay, so that's another way you can express rational numbers. We'll think of it in terms of ratio of integers. So, are these all rational numbers? Yeah, they're ratios of integers. 1's an integer, 2's an integer, 3's an integer, 4's an integer, 15's an integer, 7's an integer, -5. Yeah, all those are integers. Those are ratios of integers as long as that denominator is not 0. Now, would you say 6 is a rational number? Yes, it is, because you could write it as 6 over 1. That's a ratio of integers. -4, yeah. -4 over 1. How about 0? You could write that as 0 over 17, 0 over -4, 0 over anything. It's still going to be 0, right? So that is a rational number. It's just 17 over 0 is not a rational number. You can't divide by 0, but you can divide by any other thing. How about 4.5? Is that a rational number? Say again? Yeah, because you could write it as 9 halves. Or 4.5, terminating decimal. How about 0.7? Yes, that's 7 over 10, right? 7/10. How about 0.21? Yes, that's a terminating decimal, 21 over 100, rational numbers, okay? They're also rational because you can write them as a quotient of 2 integers, okay? And there's several different answers there. 6 is 6 over 1, or 12 over 2, or 18 over 3, or 60 over 10. There's a ton of infinite number of ratios you can do to give you 6. Does that make sense? That's what rational numbers are. Here's some more. The -4 is either 4 over -1, or -4 over 1, 8 over -2. Tons of ways you can do that. We've already said 0.7 is 7/10. 0 could be 0 over 1, 0 over 2, 0 over 3, 0 over -1, 0 over -2. What can it not be? 0 over 0. Don't do that one, okay? You cannot ever divide by 0, okay? And decimal number 0.21 is 21 hundredths. Because a rational number is a quotient of 2 integers, our previous work with division of integers can help us understand ways to various forms of rational numbers. Okay. Now, if the signs of the numerator and denominator are different, what's your rational number? If the signs of the numerator and denominator are different, what's your rational number? Negative. If they're the same, positive. Even if they're both negatives? Yeah, still positive. So the signs of the rational numbers are different, numerator and denominator are different, then the rational number is negative. If the signs of the numerator and denominator are the same, whether they're positive or negative, the rational number is positive. All right. Now here's a little hint. If you only have one negative sign, your answer is going to be negative. So if I'm simplifying a rational number, I'm first going to deal with the signs. I see here there's only one sign, put the minus here. Then, what's 8 over 2? 4, so that's -4. Even if it's here, there's only one negative sign, put the minus sign in. 8 over 2 is still 4. Okay. But here's what they're getting at. You can have that one negative sign either in the denominator, in the numerator, or out in front. It doesn't matter where the result's going to be negative. Okay? Now, if both of these are positive, that's the same as saying both of them negative, because it's a ratio, and that's still going to be 4. If there's 2 negatives, that's going to be positive. If there's no negative, it's going to be positive. So that's going to be 4 no matter what. Any questions on that? All right, so here is the general property. Now, we've been pretending these are numbers. Soon we're going to say these could be any expression at all. A negative a over b is the same as a over negative b. Believe it or not, no matter what the expressions are, they're the same, which is the same as negative a over b, okay, negative out front, as long as b is, of course, not 0. But negative a over negative b is just the same as a over b, of course, as long as b is not 0. So, give me 2 other expressions for negative 2 over 5. 2 over negative 5, there's one. And negative 2/5 is another one. Very good. Make sense? All right, good deal. Now, we'll use the following property to often referred to as the fundamental principle of fractions. We've been waiting for this one, haven't we? Okay? To reduce, and you've done this before, lowest terms or express fractions in simplest or reduced forms. All those things mean the same. If you have a ratio of 2 numbers or 2 expressions, 2 anythings, and find out you can factor that by the same quantity, or multiply by well, first do it this way. Multiply by the same quantity, then guess what? K over K, as long as K is not equal to 0, is equal to 1, you can get rid of it. So basically what they're saying, if you have any rational expression, especially a rational number, and you find the common factor in that number, factor it out, and then divide it out. Okay? And you have the result. Now this looks pretty simple this way. Let's actually do it with some numbers. Let's reduce that to lowest terms. You know how to do this. You've been doing this since grammar school, right? What would this be? Let me get my pen activated. Okay? Second? 3/4, is that what you said? How did you do that? You're right. Yeah, you notice these both are divisible by 6. This is 3 times 6 over 4 times 6. 6 over 6 is 1. That's 3/4. Isn't it? Good deal. Let's see how they did it. Any questions on that before I erase it? Now, let me show you another way of doing it before I erase it. Okay? If you didn't see that 6 was a common factor, here's what you can do. And we're going to get to this in just a minute, but I'm going to do it now. What's the smallest number that will go in, not 1, okay, that will go into 18? 2. 2 times what? 9. What's the smallest number that will go in 9? 3 times what? 3. Can't get anything else in it, right? Now, in that denominator, what's the smallest number will go into 24? 2 times what? 12. What's the smallest number will go into 12?
3.
Smallest, 2. 2 times what?
6.
And what's the smallest number go into 6? 2 times what? 3. Okay? If you couldn't see that 6 was the smallest number there, you can do this. And we're going to get to a name for this later. Y'all know what it is? What did we just do? Prime factorization. That's a prime factorization. We got down to its smallest numbers that will be. Now, 2 will go into 2 once. 3 will go into 3 once. What does that leave you with? 3 over 4. You can do it that way. So if you have big old hairy numbers that you don't see what the common factors are, just start chopping them off one bite at a time, you know. Break it down until you can get to the prime form and go with that. I probably jumped ahead, but there's no extra charge for that. Okay? Now let's see how they did it. I bet you they did it the first way because they were clever like you were. Okay? Okay? Yes, they saw that 6 was a common factor of both 18 and 24. 3 times 6 is 18. 4 times 6 is 24. So that is 3/4. Okay? Now they skipped the rest of them. So let's go back and do the rest of them. These are pretty easy. Okay? How about 40 over 48? And guess what? You can take intermediate steps. You don't have to find the biggest one. Find one that you see. What do you notice right off the top? What's that? What can you do with that? Second? Divide by 2. Okay, you're going to do prime factorization? Okay, 2 times what is 40? 20. What's the smallest number go into 20? 2 times what? 10. What's the smallest number go into 10? 2 times what? 5. That's a prime number. We're done. How about the denominator? 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Okay? What can we divide out? 2, 2, and 2. What does that leave us with? 5 over 6. Or you could have done what I would, when I first looked at this, here's what I thought. 4 will go into that 10 times, 4 will go into that 12 times. And then I'll look at 10 over 12 and say, well, 2 will go into that. So you can do it any number of ways. Biggest number, any number. Prime numbers, any way you want to do it, as long as you do it correctly. Okay? Don't do it correctly, you're going to miss it. Okay, so unless you're really lucky and undo your error somehow. How about this one? Minus 36 over 63. Oh, I didn't write that right. Like that. What would you do as an answer? I'll give you a hint what I do. Deal with the signs first. Negative. Now, I heard someone say what? 9. That's very good. 9, okay, 36 is 4 times 9, and 63 is 7 times 9. 9s go out, and that gives you negative 4 sevenths. Or negative 4 over 7, or 7 over negative 4. It doesn't matter. I usually like to write it first. So what I like to do is deal with the signs first and then do the factor. Good choice. Now, I don't know if you did it this way or not. Tell me. How's an easy way to tell whether 9 will go into these numbers? This is a real simple process. Okay, let me start up. How about 2? How can you tell if 2 will go into a number? If it's an even number. In other words, if the last digit is divisible by 2, 2 will go into the whole number. How about 3? Does anyone know the rule for 3? Add the digits together. 3 and 6 is 9. 3 will go into 9. 6 and 3 is 9. 3 will go into it. So you could have divided out 3. Here, 48. Add the digits. 4 and 8 is 12. 3 will go into 12. There's a 3. How about this one? 3 won't go into that. 4 and 0 is 4. 3 won't go into 4. So there's no factor of 3. So that's how you do 2s, 3s, 4s. If 4 will go into the first 2 digits, okay? 4 will go into 40, 4 will go into 48. Yes, you can do it that way. 5s, how do you know if it will go into 5? If 5 will go into a number? If the last digit is either 5 or 0. There's a 0, 5 went into it. These don't have 0s or 5s. No 5 in it. How about 6s? There's not really a rule for 6, but there is for 2s and 3s. So if 2 works and 3 works, like this one, 2 will go into that, 3 will go into that, therefore 6 will go into that. 2 will go into that, 3 will go into that, 6 will go into that. 2 won't go into this, and 6 won't go into that. So there's the other way. How about 7s? There ain't no rules. Okay, 7, you just have to use a calculator or something. I don't know of any rules for 7. Now 8 is almost like no rules. Look at the last 3 digits. If 8 will go into the 3 digits it goes into it, well, shoot, if you do that, I'd do a calculator anyway. How about 9? Now this is one we just did. It's just like 3. Add the digits together. If 9 will go into 9, 9 will go into 9. That worked. Add these together. That's 12. 9 won't go into 12. 9 won't go into 4. So 9 won't go into these. So those are. How about 10? Real simple. If the last digit's a 0, 10 will divide out. Okay. So those are all the rules I know right off the top. Good deal. Next time we will have the test. Remember, you can have a formula and equation sheet. Anything you want to write on a piece of paper, front and back, you can bring with you for the test. Anything you want to. You're like me a love note. I say again.
What's your rule for calculators on it?
You can use calculator. Any calculator you want. Absolutely.
Not your phone though. Right?
Huh?
Not your phone though, right?
Yeah, you can use your phone. I don't like them, but yeah, your phone doesn't act as a calculator too well. But yeah,
Oh,
if
yeah.
you want to.
Actually.
Yeah, you could look up something.
No, I was saying if you use a landscape view, it actually turns into a scientific one.
Oh, it does. I didn't know that. Okay, great.
Kind of neat.
Oh yeah, and if you haven't turned in your quiz, please turn in your quiz. Thank you.
I didn't staple it.
Okay, that's all right. I got your name on both sheets. Thank you so much.
He just taught me a new trick.
What's that?
I had no idea who did that.
If you just turn it sideways, it's scientific.
Scientific calculator. Wow, nice.
And I never.
Is that only certain levels of iPhones or?
He had an iPhone. I have
It
an
did it
Android.
on my iPhone 3, so I assumed.
3? Okay. I didn't know it did on the early ones, but okay, good to know.
That's
Okay.
on Android.
I don't have one, but okay, good to know.
Yep, good to know.
My wife's gonna give me one, I think.
I was gonna ask you, if I'm factoring, we got a bunch of different kind of methods we can use when you're factoring,
Right.
solving the equation. Okay. So if I go to factor something out, now can I do the b squared minus 4ac on any of them and just see, what my
See what your answer.
Yeah, so I can use it. So even if you don't
Be sure you get it in standard form first.
But
Equal 0, yeah. And then
then if I don't, and then if I do that, the b squared minus 4ac, if I use that on any of them, even if you don't request even if you don't suggest that we use that, I can use that on any of them to see if I will have a solution or whatever. It could tell me if I want it's an factorable or not too.
Right.
So it'd be easy.
It certainly will. And if it is factorable, and then you want to use Ms. Brown's method, you can do that.
Okay.
But if it's not factorable, you can say it's not factorable.
And then that way they'll tell me before I do all that work.
Exactly. So if when you do b squared minus 4ac, if that's not a perfect square, not factorable.
Okay.
Yeah, good deal.
So I'll see.
Uh-huh.